All right, so we're going to start our last set of factoring notes. And our goal for these notes is to factor x squared plus bx plus c. So we're going to factor a trinomial. So it has trinomial meaning 3 terms. So 1, 2, 3 terms. And it's in the form of a quadratic, so it has an x squared starting and an x term and then a number term. So you'll notice that all of these are arranged just like that. There are 3 terms. You'll see a couple, there are 2, but I'm going to show you how to write them with 3 terms, so they're going to be the exact same as all of these. You have an x squared term, the bx term, so 4x, negative 4x, 4x, x, 9x. This one's missing it, so we'll get there. And then a number term, like 3, 3, negative 21, negative 2, 14, the negative 16, etc., etc. So when you go to factor these types of polynomials, what you are going to do is we're just unfoiling them. So I'm going to show you first one way to look at it, and then I'm going to kind of show you like a shortcut. So when we go to factor this, we're going to factor them into 2 binomials. And if you look back to your other notes, we actually multiplied 2 binomials. And the first times the first always got us this spot right here. So what times what gives us x squared? And that would be, x times x. Okay. Now, your last times your last always gave us this number right here. So we have a couple options here. You could do 1 and 3, but really that's the only way 1 times 3 gets us 3. There's no other factor pair that gets us to 3, so we're going to have to do something with 1 and 3 here. And then when we were to FOIL this, what we need to happen is that when you do your first times your first, you get x squared. Your outside would be 3x. Your inside would be 1x. Okay? The only way to get 4x out of that is if it was addition here. Okay? And I'm going to show you how we can check this in a minute. And then so you'd have a 3x and a 1x, which adds to 4x. And your last times your last is 1 times 3, which is 3. So if I check this, just to check it, I would have my first times my first is x squared. My outside is plus 3x. My inside is plus 1x plus 3. And 3x and 1x does get me 4x, so this works. You're just unfoiling it, okay? Now, let me show you how you can do this with kind of a shortcut involved. Didn't want to erase my other problem. Okay, so to do this as a shortcut, what we are looking for is the numbers have to multiply to 3, and they have to add to 4. That's how I come up with 2 numbers. When I come up with those 2 numbers, that's the numbers that go right here. So numbers that multiply to 3, but when you add them, you get 4. And the only numbers that are going to work are going to be 1 and 3. When I multiply them, I get 3, and when I add them, I get 4. So that's where the 1 and the 3 come from, because the last times the last have to multiply to 3, but when you do your outside inside, you have to add those up to get that 4x. So let's try to use that shortcut and figure out these next ones have to multiply also to 3, but these ones have to add to negative 4. So what are 2 numbers that when you multiply them, you're going to get 3, but when you add them, you're going to get negative 4. So I want you to think about it. Try to come up with those 2 numbers. And we know this is going to look exactly like the last one. Your first times your first has to be x times x, so x squared. Okay? Now we just have to come up with those other 2 numbers. The 2 numbers that you should come up with are negative 3 and negative 1. When you multiply those, you're going to get a positive 3 because a negative times a negative is a positive. But when you add negative 3 and negative 1, you get negative 4. So x minus 3 and x minus 1. Now if I refoil this, again, you can check this. X times x is x squared. X times negative 1 is negative 1x. Your inside is minus 3x. Your last is plus 3. X squared, this turns into minus 4x, and then plus 3. So it works. You didn't change the value, you just changed how it's written. Now I don't want to put that on my problem because this is technically my final answer because this is factored form. So this is factored form. And this here is standard form. Okay, so that's the difference. All right, so let's try this next one. It wants to multiply to what number? And then add to what number? So see if you can figure out what we're looking for here. And then what are those two numbers? So go ahead and hit pause and try that right now. Try to fill that in. You should have that it has to multiply to negative 21 and it has to add to 4. What were the two numbers that you came up with? 7 and negative 3 should be the two numbers. When you multiply those, you get negative 21. When you add them, you're going to get 4. So again, our factored form, start off by writing it like this, and then when we found those two numbers, that tells us we have x plus 7 and x minus 3. Again, you can FOIL this to double check that it is equivalent to x squared plus 4x minus 21. One of them is just written in factored form, the other is written in standard form. So, try number 4 now. So go ahead and hit pause and then try number 4. All right, so it looks like we're looking for a number that multiplies to negative 2, and this has to add to 1. Remember, if there's nothing in front of the x, it's an invisible 1. 1 times x is just x, okay? So it's adding to 1. So what two numbers multiply to negative 2, but add to 1? And the two numbers you should come up with are 2 and negative 1. So when we go to write our factored form here, we have two binomials that multiply. The first times the first has to give us x squared. So x times x plus 2 and minus 1. Now if we go through and we FOIL it, we should end up with x squared plus 1x minus 2. And as long as we get that, then we know we did not change the value of this. We just changed how it was written, and we're good to go. Why don't you try number 5 on your own, completely on your own? So go ahead and hit pause, try number 5 on your own, and when you get your final answer, just put your pencil down. You should have gotten x plus 7 and x plus 2 as the factored form. All right, so number 6 is the one I said it looked a little bit different, but I'm going to show you how you can write this so that it looks the exact same as the rest of them. If we write this as x squared plus 0x minus 16, those two things are equivalent because you don't have an x term. It just means that that term is 0x. So when we go to do this one, we're going to do it the exact same way. We just have to know that that middle term is a 0. Okay, so it has to still multiply to negative 16. But what happens when we add them, we have to get 0 because there are 0 x's. So what two numbers multiply to negative 16, but when you add them, you get 0? Negative 4 and positive 4 are going to add to 0, and when you multiply them, they multiply to negative 16. So that allows us to factor this because we have our two binomials, x times x, to get us the x squared for the first term, and one of them is going to be plus 4, and the other is going to be minus 4. And you'll notice that when you FOIL this, you will get 0x for that middle term because your outside is going to be negative 4x, and your inside is positive 4x, which does get you 0x, and your last is 4 times negative 4, which is negative 16. And then we don't have to write this term, so that's why we write x squared minus 16, because this term just multiplies to 0. Anything multiplied by 0 has to be, anything multiplied by 0 is going to be 0 here. So you're left with x squared minus 16. Okay. Let's try number 7. Number 7 has to multiply to 9, but when we add it, we're going to get 6. So these two numbers have to multiply to 9, but add to 6. What are the two numbers going to be? 3 and 3. 3 times 3 is 9. But when you add them, you get 6. So your first times your first still has to be x times x. So then with the two numbers being 3 and 3, we're going to have x plus 3 and x plus 3. And then one additional step you can do is, because those factors are the exact same, you could write it x plus 3 squared. Now, do you have to? No. As long as you had this one, that would be sufficient enough. All right, so let's try number 8. Why don't you guys go ahead and try number 8 on your own, and then, so hit pause, try number 8, and then hit play to see if you got it right. So if you did this one correctly, you should end up with the factored form is x minus 4 times the quantity of x plus 3. Now, try number 9 on your own. Remember, number 9 is going to be similar to number 6, where you're going to want to change the way it's written so you can figure out what they need to multiply to and what they need to add to. So go ahead and hit pause now and try number 9 on your own. If you did this one correctly, you should have the quantity of x plus 7 times the quantity of x minus 7. All right, so you have one more. Try number 10 on your own. So go ahead and hit pause, try number 10, and then when you hit play, you can see if you got it right. So on this one is x minus 4 quantity squared, or you could write it x minus 4 times x minus 4. Either of those answers would be acceptable.